Hello everyone, today we are going to learn the basics about Unix commands. This video will show you how various commands are used in Unix followed by examples to make it easier to understand. We will start with file and path names commands. From there we will move on to the pipes and filters in Unix and ultimately we will see how process control is done. Files and file names. A file is a basic unit of storage, usually storage on a disk. Every file has a name. File names are case-sensitive. Unix file names can contain any characters, although some make it difficult to access the file, except the null character and the //. Unix file names can be long. How long depends on your specific flavor of Unix. Directories. A directory is a special kind of file. Unix uses a directory to hold information about other files. We often think of a directory as a container that holds other files, or directories. A directory is the same idea as a folder on Windows. More about file names. Every file has a name, at least one. Each file in the same directory must have a unique name. Files that are in different directories can have the same name. Files that start with a are, by default, hidden by many utilities. Here is a hierarchical diagram depicting the file system of the Unix environment. Unix file system. The file system is a hierarchical system of organizing files and directories. The top level in the hierarchy is called the root and holds all files and directories in the file system. The name of the root directory is /. Path names. The path name of a file includes the file name and the name of the directory that holds the file, and the name of the directory that holds the directory that holds the file, and the name of the up to the root. The path name of every file in a given file system is unique. To create a path name you start at the root, then follow the path down the hierarchy including each directory name and you end with the file name. In between every directory name you put a /. This diagram shows how path names are implemented in Unix. Disk versus file system. The entire hierarchy can actually include many disk drives. Some directories can be on other computers. Below we have the diagram differentiating the disk from the file system. Command, basic syntax. Shell expects the first token, for now, to be a command. Subsequent tokens are arguments. Arguments that start with a are called options, generally, POSIXly. lso/home/schmidt/home/schmidt/public. O provides a long listing. The final two tokens are directories to be listed. Commands for traversing file system. ls lists contents of a directory. all files. L long listing. pwd print working current directory. cd change directory. w/out argument takes you home. Man pages. To get information about anything that's been properly installed, use man. Man ls. Man cat. Man. You can do a keyword search. Man k keyword. Linux boxes also have info pages. The ls command. The ls command displays the names of the named files. Give it the name of a directory as a command line argument to list all the unhidden files in the directory. By itself, it lists the current working directory. Command line options. We can modify the output format of the ls program with a command line option. The ls commands support a bunch of options. L-long format includes file times, owner and permissions. Compared to O. All shows hidden asterisk files as well as regular files. F includes special char to indicate file types. C place into columns. Asterisk hidden files have names that start with cd, change directory. The cd command can change the current working directory. cd change directory. The general form is cd directory. By itself, returns you to your home directory. Viewing files. Cat, concatenate, send to stdout. View contents of text files. Less, more, paging utilities. Hit H for help. Q to quit. odd, octal dump. For viewing raw data in octal, hex, control chairs, etc. Copying, removing, linking. rm, remove file. rm tilde/tmp/download. mv, move, rename file. mvold.file. /author/new.name. cp, copy file. cp someter/file/file.copy. lane, create hard, a node, or soft, symbolic links to a file. Commands for directories. mkdir make directory. rmdir remove directory. Directories can also be moved or renamed mv and copied cpr. Commands for archiving. tar, tape archive. Makes a large file from many files. Gzip, gunzip. Compression utility. tar on Linux does gzip compression with the Z option. $tarczf 571 back.tgzcs 571. $tarxzf asn1.tgz. File attributes. Every file has some attributes. Access times. When the file was created. When the file was last changed. When the file was last read. Size. Owners, user and group. Permissions. Type, directory, link, regular file, etc. Articles, access control lists, not today. File time attributes. Time attributes. When the file was last changed LSL. Sort by modification time ls lieutenant. File owners. Each file is owned by a user. You can find out the username of the file's owner with the L or O option to ls below. This is how LSL works. File permissions. Each file has a set of permissions that control who can mess with the file. There are 3 types of permissions. Read abbreviated R. Write abbreviated W. Execute abbreviated X. There are 3 sets of permissions. User. Group. Other, the world, everybody else. LSL and permissions. RWX RWX RWX. User group others. Type of file. Plain file. D, directory. S, symbolic link. Others. RWX. Files. R, allow to read. W, allow to write. X, allow to execute. Directories. R, allow to see the names of the contents. W, allow to add and remove files. X, allow to enter the directory. Changing permissions. The chmod command changes the permissions associated with a file or directory. There are a number of forms of chmod. This is the simplest. Chmod mode file. Chmod, numeric modes. Consider permission for each set of users, user, group, other as a 3-bit £. R4. W2. X1. A permission mode for all 3 classes is a 3-digit octal £. These are a couple of examples showing how chmod works. Chmod, symbolic modes. Can be used to set, add, or remove permissions. Mode has the following form. Some examples on chmod. Pipes, connecting processes. A pipe is a holder for a stream of data. A pipe can be used to hold the output of one program and feed it to the input of another. Asking for a pipe. Separate 2 commands with a pipe character. The shell does all the work. The Unix philosophy. Stringing small utilities together with pipes and redirection to accomplish non-trivial tasks easily. For example, find the 3 largest subdirectories. Filters. Programs that read some input, but don't change it, perform a simple transformation on it, and write some output, test it out. Some common filters. WC, word count, line count, character count. Trail, Translate. Grep. Grep. Search files using regular expressions. Sort. Sorts files by line, lexically or numerically. Cut. Select portions of a line. Unique. Removes identical adjacent lines. Head. Tail. Displays first, last, end lines of a file. Pipes and combining filters. Connect the output of one command to the input of another command to obtain a composition of filters. Process control. Processes are run in a subshell by default. Subshells inherit exported variables. Each process has an ID, PID, and a parent, PID. Use the PS utility to look at some processes. Use the F option for a long listing. Use the E option to see more processes, all of them. Killing a process, not usually nice. The kill command sends a signal to a process, the given PID. By default, sends terminate, which asks the process to finish, so that it may do cleanup. Use -9 to send a kill won't be ignored, but no cleanup. My MP3 player hangs once in a while. Job control. The shell allows you to manage jobs. Place jobs in the background. Move a job to the foreground. Suspend a job. Kill a job. Background jobs. If you follow a command line with &, the shell will run the job in the background. You don't need to wait for the job to complete, you can type in a new command right away. You can have a bunch of jobs running at once. You can do all this within a single terminal window. Listing jobs. The command jobs will list all background jobs. The shell assigns a number to each job. This one is job number 1. Suspending and resuming the foreground job. You can suspend the foreground job by pressing Ctrl+Z. Suspend means the job is stopped, but not dead. The job will show up in the job's output. You give FG a job number as reported by the jobs command, preceded by a %. Without an argument, FG brings the last job forward. Placing a suspended job in the background. If it's in the foreground, suspend it. Use berg, just as you did FG, to let a suspended job continue in the background. Killing a job. Kill may also take a job number or even a job name, introduced by %. Hope you enjoyed the video. Do like and share it. Thanks for watching. Peace.